Section 6.4 is on completing the square. So completing the square is something that maybe you didn't do. Yeah? I'll come around and get it later. All right, it's something that you probably didn't do in Algebra 1. It's a little bit different. Factoring works for a lot of things, but it doesn't work for everything. So completing the square will work for everything. So even if you have square roots or i's in your answer, it's going to work. So the first one, so it says, I have 3x squared minus 5 equals 67. So I can solve this without factoring. I can add the 5 to the other side. So I have 3x squared equals 72. I can divide by 3. So I have x squared equals 24. And I can take the square root. Whenever I take a square root, I don't forget that I need a plus or minus. So I get x equals plus or minus the square root of 24, which 24 breaks into, right, you can break it into square root of 4 and square root of 6. So it's 2 root 6, so plus or minus 2 root 6. You could also do your factor tree like we've talked about before if you need to. It doesn't matter. You should be getting to the point where you can think about the perfect squares that go into it, though. So that's your answer. So you have two answers, 2 root 6 and negative 2 root 6. Okay, the next one. So I'm going to subtract the 11 over, so I get 4z squared. Subtracting 11 gives me 48. Divide by 4, divide by 4. So I get z squared equals 12. I take the square root of both sides, plus or minus. So I get z equals plus or minus root 12, which 12 breaks into 4 and 3. So plus or minus the 2 square root of 3. All right, so I call this the square roots method. So you might want to write that on your paper because I refer to it as the square roots method all the time. So if we can get something into the form like x squared equals a number, or even if I had like x minus b squared equals a number, then I can do the square roots method. So these next two, I'm actually going to do the same method. It's just going to be a little bit different because I'm noticing that if I have c squared minus 6c plus 9, that's what we call a perfect square trinomial. Okay, so basically when I factor it, it ends up being c minus 9, or sorry, not c minus 9, c minus 3, right? So c minus 3 times c minus 3. So you end up getting c minus 3 squared equals 10. So I can do the square roots method with this one as well. So all I'm going to do is I'm going to take the square root of both sides. So square root and write my plus or minus. So I get c minus 3 equals plus or minus the square root of 10. And then I'm going to add the 3 over. Now when you add the 3, it's not square root of 13, right? Square root of 10 plus 3 is not square root of 13. Square root of 10 plus square root of 3 isn't even square root of 13, right? You can't do that. So I'm just going to add the 3 to the other side, and I'm going to put it in front. I'm going to have 3 plus or minus the square root of 10. They're not like terms, so I can't combine. So I have two answers. I have 3 plus the square root of 10, and I have 3 minus the square root of 10. So I just kind of slip it in right in the front there. All right, so the next one, same idea. This y squared plus 12y plus 36, that's a perfect square. It factors into y plus 6 times itself. So I write it as y plus 6 squared is equal to 49. So I can take the square root, write my plus or minus.
Could you just put 7 right here?
So I get y plus 6 equals plus or minus 7. Now this is what people always mess up on in the test. They always want to subtract the 6 and then they write plus or minus 1. Right? That's not how this works. So write your two separate answers. So you're going to subtract the 6. So just like before, I'm going to put it in the front. So negative 6 plus or minus 7. But then I'm going to think about what those two answers are. So if I have negative 6 plus 7, I get 1. But if I do negative 6 minus 7, that's negative 13. So you get two answers. It's not like plus or minus 1. It's negative 13 and positive 1. Yes?
Why didn't you?
Yeah, in this one, on number 4, you could have easily subtracted the 49 from both sides. Right? And you could have gotten negative 13 equals 0, and you could factor. So you can do y minus 1 and y plus 13. Yeah, and you get two answers. You get y equals 1 and you get y equals negative 13. But could you have done that on this last one, on number 3? C squared minus 6c minus 1 equals 0. Can you factor that? No. Okay, so complete the square. We've learned this method because it's going to work on answers that are square roots and i's. It's going to work on everything. Factoring only works on some things. Sometimes it's prime and you can't factor. So how do you find the x-intercepts then? You would do this method. All right, so next step. So our goal is to try to get things into this different form, like into the completing the square form, so I can do the square roots method. Okay, so we have a little box that tells us the steps. So it says we can use the above methods if we get our equation into one of those 2 special forms. So this process is called completing the square. So it says get your equation in the form x squared plus bx equals c. So in order to do this, you might have to divide by the number in front of x squared. So in other words, you need a 1x squared. You don't want like 4x squared or 3x squared. You always want it to be a 1 out front. Okay, so when you do that, you might even have fractions, which I know you guys are just going to love. All right, so we might have some fractions. Step 2, you're going to have it and square it. So you're going to take the term in front of, like the number in front of the x term, and you're going to divide it in 2 and square it. So add this result, which is b divided by 2, quantity squared, to both sides of the equation. This then completes the square. It makes it so you have a perfect square, and then you can do that square roots method. Don't forget your plus and minus sign. Yeah, Catherine?
What did we do step number 2?
We haven't done it yet. Okay, so this next one. So we're going to solve each equation by completing the square. So the last one, so Catherine's saying, when did we do that in number 3 and number 4? We didn't. It was already set up so that we had a perfect square here. But what if we don't have a perfect square there? That's when we need to complete the square. Okay, so this next one. So I have x squared equals 12x minus 20. So I need to get all of my x's on one side. So x squared minus 12x equals negative 20. And I'm going to have it and square it. Okay, so I'm going to take the number in front of my x term. I'm going to divide it by 2, and I'm going to square it. So I'm going to take negative 12. Well, maybe I'll write out b over 2 squared. So b divided by 2 squared. So I'm taking my negative 12, I'm dividing it by 2, and I'm squaring it. So I'm going to have negative 6 squared, which is 36. That's going to be what I add to both sides. So I'm going to have x squared minus 12x, and then I'm going to have plus 36. I usually put a little box around it so I remember that's the part that I completed the square on. And I add it to both sides of the equation. I want to keep my equation balanced. So whatever I do to one side, I do to both sides. Okay. So when we do that, we've now completed the square. We've made it so that this side factors into x minus 6 times x minus 6. And then I have negative 20 plus 36, so I get 16 on the right side. So I have x minus 6 squared equals 16. Do you guys understand what we're going to do next? So now we're going to take the square root, we're going to write plus or minus, and so on. So I'm going to do the square root of both sides. I'm going to write my plus or minus. So I get x minus 6 equals plus or minus 4. I add the 6. So I have 6 plus or minus 4. And then I find my 2 answers. So be really careful. It's not plus or minus 10, right? It's 6 plus 4 is 10. 6 minus 4 is 2. So it's 10 and 2. So when you get nice like integer answers or even like fraction answers, like if I had x equals 3/5 and x equals 1/2, like it would have worked out if you had factored originally. But if you're getting square roots or i's, like you would not have been able to factor originally. So this is a nice one, like on the test, if I say do it with a complete the square method, check it with factoring because you knew that it was a nice like rational answer. All right, so the next one. So I have my x's on one side, but I need it to be a 1x squared. I don't want 3x squared. I want 1x squared. So I'm going to divide both sides by 3. So when I do that, I get x squared minus 8x equals 9.
Did you have not divided by 3 and you said it?
Nope, if you did not divide by 3, the complete the square will not work. It always needs to be x squared plus bx equals c form. All right, so we're going to complete the square. So I'm going to take my -8, I'm going to divide it by 2, and I'm going to square it. Now, some of you guys are going to be really good at this. You're not going to have to write it off to the side. Can some of you guys see already what you're going to add to both sides? Ian, what do you see?
16.
16. Do you guys see it? So he's realizing that if he divides it by 2, he gets -4 squared. This gives him 16. It ends up giving him the perfect square. So I still will write it off to the side for your notes. So b over 2 squared. So you get -8 over 2 is -4 squared. So you get 16. That's going to be what you add to both sides. So I'm going to have x squared minus 8x plus 16. And I'm going to have 9 plus 16. So I added the 16 to both sides. On the left-hand side, this creates a perfect square. I have x squared minus 8x plus 16. If I factor it, it's going to be x minus 4 times x minus 4. So x minus 4 squared equals 9 plus 16 is 25. So I take the square root of both sides and I write my plus or minus. So I get x minus 4 equals plus or minus 5. I add the 4 over. So I get 4 plus or minus 5. So I get two answers. I get 9 and I get 4 minus 5 is -1. You guys understand? All right, so those are the ones that are like nice answers in the end. Oh, how nice. 9 and -1. You know I'm going to give you some hard ones, right? It's coming up. All right, so let's try some that are maybe going to have like square root answers, fraction answers, eyes. Oh, we got all kinds of fun stuff. All right, next one. Pull this one down a little bit. All right, so I have 18x plus 3x squared equals 45. So it's almost in that form where I have like x squared plus bx plus c. But I need to first write my x squared first. And I also need to divide by the 3. So I want a 1x squared. So when I do that, I get x squared plus 6x equals 15. Now this one would not factor. So you can check, like if you subtract the 15 over, do you guys see that's not going to factor? Right? Because you could have 5 and 3, you could have 15 and 1, but they're never going to combine to be that 6 in the middle. Okay, so it doesn't factor. So that means it's going to be a weird answer. There's going to be like square roots or there's going to be eyes. Okay, so I'm going to complete the square. So I'm going to do my b divided by 2 squared. So 6 divided by 2 is 3 squared. Gives me 9. Nope, it's b over 2 squared. Don't get confused with negative b over 2a. We did that before, the vertex form, right? Okay, so I'm going to add 9 to both sides. So I have x squared plus 6x plus 9, and I have 15 plus 9. So when I do that, I get x squared plus 6x plus 9 makes x plus 3 times x plus 3, right? X plus 3 squared. So again, if you need to write that out and just factor that and say, oh yeah, it's x plus 3 times itself, that's fine. But really the number that you're getting is what you had before you squared, right? It's the 6 over 2, it's 3. Okay, because it has to multiply by itself to give you 9. All right, and it equals 24. Square root of both sides, plus or minus. So I get x plus 3 equals plus or minus the square root of 24. 2 root close 6. Yep. And then subtract the 3 over. So we leave our answer as x equals -3 plus or minus 2 root 6. We cannot combine the 3 and the 2. We can't make it like -1 root 6. A lot of people try to do that. You can't do that though because they're not like terms. Right? Remember we talked about adding and subtracting things with roots. You can't add them unless they have the same root part. So we're done. Okay, number 4. So we're going to add the 4 to the other side. We're going to do our b over 2 squared. So if I do b divided by 2 squared, I get 8 over 2 squared. So I get 4 squared, which is 16. I'm going to add that 16 to both sides. So x squared plus 8x plus 16 equals 4 plus 16. So I added to both sides. I'm going to factor. So if you do your two sets of parentheses and you try to factor, it ends up being x plus 4 times x plus 4. So x plus 4 squared equals 20. Square root of both sides, square root of both sides. So I get x plus 4 equals square root of 20. How's that reduced down? 2 root 5, yep. And then just subtract the 4 over. So your final answer is going to be x equals negative 4, and then plus or minus 2 root 5. That's it. You guys understanding? You ready for an I one? I know you thought I's were going to go away. They don't. Just like factoring, like when you learned it in Algebra 1 where you're like, oh, we don't need to factor. How important is this? It's just one chapter at the end of the year. Yeah, it comes back every year. Darn. All right, so anyway, so subtract the 6 over. So I have x squared minus 4x equals negative 6. What am I going to add to both sides? Because negative 4 divided by 2 squared is negative 2 squared, which is 4. So I'm going to have x squared minus 4x plus 4 equals negative 6 plus 4. So when you factor the left side, it's x minus 2 times itself. So x minus 2 squared equals negative 2. Uh-oh. What's different about this one? You're going to have an imaginary number, right? Because you're going to take the square root and you're going to have the square root of a negative number. You're saying that something squared equals negative 2. The only way for that to work is if it's an imaginary number. So take the square root and write your plus or minus just like normal. So on the left, we do get x minus 2. But on the right, we have plus or minus the square root of negative 2. And we're like, square root of negative 2. So remember, if you have a negative under a square root, I want you to think of it as the square root of negative 1 times the square root of 2. Because the square root of negative 1 is I. So we get I root 2. So we have x minus 2 equals plus or minus I root 2. So a lot of times you'll hear me say things like, pull out the negative and write it as an I. That's what's happening. You're doing the square root of negative 1. And when you do that, you get an I on the outside. So your final answer, you just add the 2 over. So 2 plus or minus I root 2. And you leave it like that. It wasn't as bad as you thought it was going to be, right? What if you had the square root of negative 4? What's the square root of negative 4?
2i.
2i, right? Square root of 4 is 2. Square root of negative 1 is I, so 2i. All right, next one's going to have fractions. So I'm going to add the 10 over. So I'm going to have 3x squared minus 6x equals 10. And I have to divide by 3 because I need a 1x squared. So I get x squared minus 2x equals 10 thirds. All right, so I'm going to do my b over 2 squared. So I'm going to take my negative 6, I'm going to divide by 2, and I'm going to square it. So I get negative 3 squared, which is 9.
You complete.
Oh, whoops. Yeah. Darn. So Ian got me, didn't he? Bonus point for Ian. All right, so negative 2 over 2 squared. So I get negative 1 squared, which is 1, right? So I'm going to have x squared minus 2x plus 1 equals 10 thirds plus 1. So you want to get common denominator, so you're going to multiply the 1 by 3 over 3. Right, or you're going to change the 1 to 3 over 3, basically. So you get 10 over 3 plus 3 over 3, which is indeed 13 thirds. And on the left side, you're going to factor. It's x minus 1 times itself, so x minus 1 squared. All right, we're going to take the square root of both sides. Square root, plus or minus. Yeah. So I get x minus 1 equals plus or minus the square root of 13 over 3. So that's the square root of 13 over the square root of 3. Which means you have a square root in the denominator, so you need to multiply by root 3 over root 3. We're almost done, I promise. So I get x minus 1 equals plus or minus the square root of 39 over 3. So last step, I want x equals, just add the 1 out front, right? So you're going to get x equals 1 plus or minus the square root of 39 over 3. Oh, I can't even write the 3. Ran out of room. Okay, there we go. Can you read that? Square root of 39 over 3. Rough. Oh man, square roots and fractions, I'm just the worst.
That's too much.
Happy Thanksgiving to you guys. Yes.
I need to be the person to ask this question.
Mm-hmm.
What does this mean?
Oh, it's allowing us to solve things that we can't factor. So all this, we wrote prime, man, solve it.
How can we write it down to something? It's like,
It's going to be really important when we're graphing funny things later, when we're graphing ellipses or ellipses and hyperbolas. It will be important. So you do need to learn this method. All right, next up. So how about you guys try number 7? Whoops, I tried to drag it down. Try number 7, and I'll come around. All right, here we go.
can we just factor 7?
I don't think it, does it factor? I don't know if it factors or not. I don't know. All right, so anyway, so we're going to divide by 8 and divide by 8. So when we do that, we get x squared plus 1/2 x equals 12 over 8 reduces to 3 over 2. We get that. So we're going to do our b over 2 squared. So I get my 1/2 divided by 2 squared. So that I heard a lot of conversation, like 1/2 divided by 2. Isn't that 1/4? Yes. Say it with confidence. It is 1/4. You could also rewrite, if you need to see it this way, 1/2 divided by 2, which is 1/2 times 1/2 squared. So 1/4 squared, which is 1 over 16. So you should have gotten 1 over 16. Did you guys get that somehow? So you're going to add to both sides. So I'm going to have 1/2 x plus 1 over 16 equals 3 over 2 plus 1 over 16. So I added to both sides. I'm going to multiply by 8 over 8. So that when I combine, I have 24 over 16 plus 1 over 16. So I get 25 over 16. So yes, it would have factored originally. Some of you guys were asking. So I have x plus 1/4 squared. Did you guys get that? Basically, it's what you had right before you squared it, like the 1/4. So it's going to be x plus 1/4 squared equals 25 over 16. So you then take the square root of both sides. Square root plus or minus. No, because you're the 1 over 16 as well. So you add them. Okay, so you get x plus 1/4 equals plus or minus square root of 25 over 16. 5 over 4. Take the square root of both, right? And then subtract your 1/4 over. So it's negative 1/4 plus or minus 5/4, which is 2 answers. So if I do the negative 1/4 plus 5/4, you get 4 over 4, which is 1. And if you do the negative 1/4 minus 5/4, you get negative 6 over 4, which is negative 3 over 2. So those should be your answers. Did anybody get it all the way? 1? All right. Yes, this one is one that factors. But remember, I'm going to give you ones that probably don't factor on your test, right? Or I'll say solve using any method, and if you realize you can factor, then that's good. But yes, it's mostly used for square roots and for I answers. But it's also, like I said, it's going to be used eventually like for graphing. So we'll talk about that later. All right, so can we stop here and you guys work on your homework and then ask me questions if you get stuck?